Yes, class. Am I audible?
Yes, ma'am.
All right.
Yes.
So, who all have joined? Priya, Amna, Austin, Deborah, Fadil, Faiza, Humam, Shavesh, Sidra. All right. See, in the last class, we started with ray optics. These were the basic phenomena which we discussed. More than this, the important part which we had discussed were laws of reflection. So the first law of reflection says that angle of incidence is equal to angle of reflection. So what was angle of incidence? Angle of incidence is basically angle between the incident ray. And what is the incident ray? Incident ray is the ray of light or a part of the light which strikes the surface first. So this is the incident ray. So, and what is meant by normal? We basically draw a perpendicular line. This is an imaginary perpendicular line drawn on the surface, which is known as the normal. And third one that we have is known as the reflected ray. This means this is the ray which bounces back on striking of an incident ray. Basically, you can say this. So angle of incidence is angle between this incident ray and the normal. This is known as angle of incidence. And the angle that is formed between the reflected ray and the normal is known as angle of reflection. So these are just the terminologies. Basically, laws of reflection say angle of incidence is equal to angle of reflection. Angle I is equal to angle R. Second says that incident ray, normal, and reflected ray, all of these three lie in the same plane. So what is meant by this when I say when they lie in the same plane means either if the incident ray is striking on the XY plane, then bouncing back of light, the reflection phenomena will also occur in the same plane. This occurs in the same plane. Suppose this example I told you that XY plane is there, light is incident in the XZ plane. So normal will also be drawn on the XZ plane and bouncing back of light will also occur in the XZ plane. Fine. These were the two laws of reflection. So mirrors we had seen concave mirrors, convex mirrors. Bulged part when it is silvered and inner concavity is present for reflection to occur. This is known as concave mirror. And in mirrors, you have these as common. Second, you have convex. See, when we talk about lens, then convex lens become important. Moreover, we'll be studying everything. So you have to pay attention to convex mirror also. So convex mirror means the bulged part is available for reflection to occur and the inner concavity is present for silvering. All right. So these were the very basic terminologies which we had seen. Out of these, all these are important actually. Principal axis, pole, focus, focal length, radius of curvature, center of curvature, all of these. Okay, lastly, we had stopped at the sign convention, new Cartesian sign convention. So basically, I told you anything that is taken along the incident ray, that is towards the mirror, it is always taken as positive. And if you're moving away from incident, it is negative. But how do you move towards or away from it? From the pole of the mirror, you begin the motion. Wherever the object is kept, from the pole, you begin the motion. That becomes the ray, the direction of the light. All right, incident ray is there, that becomes your direction. So you can check whether you are along the direction or opposite. Also, this is very helpful now because we'll be seeing images also. So when an object is present, if it is kept above the principal axis, its height is positive. If it is kept below the principal axis, it is negative. Fine. These are the new sign conventions. So this, I think you people wrote. So we have to start with the rules for drawing ray diagram. See, basic rules for drawing ray diagrams we have to understand. So this is a which type of mirror? Convex or concave?
Ma'am, convex.
Convex. Concave. Yes, Chavez. Chavez, right? It's a concave mirror. See, bulged part is silvered. Inner surface is present, the inner
Yes, ma'am.
concave.
Yes, ma'am.
Okay. So this is present for the reflection too. So it's a concave mirror, not a convex. Now, rays, suppose they are falling from infinity and they have strike it. So rays, they are falling from infinity. Object, it means your object is kept over here. We are not going to define infinity. Where is the object at precise location? No, light rays are coming simply. Main property is that, see, they are parallel to the principal axis. This is our principal axis. Light rays are parallel to it. Now, the first rule for drawing ray diagram says that whenever, firstly, these rays have to be parallel to the principal axis and coming from infinity. These are the 2 points, right? If this occurs, then the ray of light on reflection and after obeying the laws of reflection, this passes through the focus. Like this. This is the first rule. Fine. What is the condition for it to pass?
Ma'am, always it will pass through the focus.
Yes, if it is, if the object is present at infinity and light rays are parallel to the principal axis. Let me mention this also. Parallel to the principal axis. Also, object is already there at here at infinity. Secondly, if reverse occurs, suppose a ray of light, because always it's not possible that the ray of light is falling exactly parallel. It can happen, it is falling at a certain angle. Suppose that this ray of light has passed through the focus. This ray of light, object was somewhere and somewhere here. So from the object, rays of light have gone. Again, the mirror is the same. So this becomes exactly reverse. If it is coming and passing from the focus and striking the mirror, then the ray of light becomes parallel and goes to infinity. This is the rule, that the ray of light will become parallel and it will go to infinity. So this is exactly the reverse. This is exactly the reverse of what we have seen in the first law. First law said that if a ray of light, this is coming from infinity, right? So what happens if the ray of light is coming from infinity, like infinity was here, ray of light was coming like this. This was the condition. Now what will happen? It's just that reverse will occur. Here, just the reverse will occur. Means now the image will be formed at infinity. The image will be formed at infinity. An object is present somewhere at an angle that the rays of light have touched the mirror and are becoming parallel now. So it's just the reverse of what you have seen in the first law. Fine. So you have to be careful where the image is formed. More than where the image is formed, you have to be careful where the object is kept, because image will be formed accordingly. Now the third rule. Third rule is very easy. Third rule basically says that if a ray of light is present and this is passing through the center of curvature and has hit the mirror, then what has happened? This was the path of the ray of light. It has, instead of crossing the sea, if it crossed the focus, then it would have been parallel. Now what is happening? Object is kept somewhere that the ray of light is passing through the curvature. So when it will go, it will bounce exactly with the same angle. Means the angle of incidence and angle of reflection both are 0 in this case. Because see, normal must have been made. So angle of incidence is also this. And angle of reflection is also this. That's why the ray of light which was coming is striking back. The angle between incident ray and normal is 0. So it bounces back exactly. That is it retraces its path. Basically, this retraces the path. Also, don't be so firm that this only has to be the direction. When I'm drawing all these things, see, suppose this mirror is present. This is center of curvature. So ray of light can pass like this also and then get bounced back. If I have drawn this is the center of curvature, suppose this is the focus. So it can also happen that ray of light is coming from the focus like this, and here it is becoming parallel. So do not just remember and learn it like this. Fine, one more rule is left. See, this rule, when the ray of light, this is incident at the pole. Directly if the ray is incident at the pole, this is the incident ray. Then what happens? See, here the angle of incidence is made. This acts as the normal principal axis and normal both are coinciding in this case. So according to the laws of reflection, this will go back with the same angle like this. And angle of I is equal to angle of R according to the laws of reflection. According to the laws of reflection. So incident ray has struck the mirror at an angle, some angle of incidence. Normal is their angle of reflection. So this is the incident ray, this is the reflected ray. These are the 4 rules. Now these are the universal rules. Like in every case, we have to obey these rules. But how do we have to draw for the different positions of objects? That is different. That also we'll see right now. First, copied down rules for drawing ray diagrams. Which part, Hari, if you have not understood this diagram? See, this is a mirror. This is the principal axis. In the last class, I have discussed. Center of curvature is the actual center of the entire circle to which this was a part of. Here is the focus where the image will be, the rays will be concentrated. So object is kept at infinity. Light rays are coming from infinity, and one more condition, parallel to the principal axis. So it gets reflected, and the reflected ray has a property to pass through the focus exactly. That's what it over here. Clear, Tarif? Where will be the image formed? See, suppose image is formed at the focus. How will you know? See, suppose light rays are there. So light rays are coming from the convex. We'll see this. See, this is separate rule. We'll apply all the rules together. No, here I haven't taken the second ray from the center of curvature. If I take the ray from center of curvature, it will come here. So here intersection will be there. So there will be an inverted image formed over here. That we'll see. How image formation will occur, that we'll see separately. We have to apply all the rules. These are single separate rules. object in this one, second image, this one, object is kept at an angle here. This is I've made no O, from where the rays are passing through the focus and becoming parallel back.
Ma'am, so when it passes through the curvature, there will be no image formed?
No, image will be formed. This is a rule. See, image, why you people are focusing on image formation? Image formation, we will see it separately. This is just one ray of light, no? One more ray of light will also go. Rays will intersect, then only images are formed. If a ray of light is just present, how will you say an image is formed? Right? Light rays are traveling everywhere. Everywhere you do not see the images. You only see the image where the light rays intersect. Even you are able to see something is because images are intersecting at your retina because of the convex lens present in your eyes. So images will be light rays will be intersecting. There somewhere we'll be having the at the intersection the image formation.
Ma'am,
Okay.
can you explain me the difference between first and second ruling? I'm getting
Between
confused.
which one, Fia?
First and second ruling, what is the difference, ma'am?
Between these two.
Yes, ma'am.
In this, light rays are coming from infinity and passing through the focus. In the second second one, rays are coming from the focus and passing through and going back to infinity. Just reverse of it, reverse path. It means suppose you have this case, you will make it parallel and make it back to infinity. And when you will see rays are coming from infinity and parallel, then this is the generalized case which we take. Usually image is for the objects and it will pass through the focus. This is the difference. Clear?
Yes, ma'am.
Fine. Now see, we'll be now starting with the image formation of the image when the object is kept at different positions. So first we'll start with beyond C. Beyond C means center of curvature is present. Now, before center of curvature, anywhere if you keep the object, anywhere, here, at infinity, here, before the center of curvature, like this, A, B, this is the height of the image AB, this is the object. Fine, this is the height of the object AB, this is the object. I have kept it at the center, before the center of curvature. Before the center of curvature, anywhere you can keep it. Now, according to the laws which we have studied, what was the first law? Light rays coming, see, obviously from one end, the rays will be parallel. And if the rays are parallel, they'll pass through the focus. Like this. Second, center of curvature rule also we have to follow. So if the light rays are falling on the center, along the center of curvature, it will retrace its path. Now see, and I'll ask all of you to have pencil, proper scale, protractor with you all to draw all these rays, then it will be perfect. It's difficult for me to draw it on the screen so well. So what you do, you people draw this also with the help of protractor or compass, center of curvature, focus, object, and all these rays properly with the help of scale. Then you will get it exactly the way the images have to be there. Though it is correct here also, the image formation, see, this is the image formation. So if this was the head, this is the head, let's say A dash, this is B dash, this is the image. Now look class, what are the characteristics? Where is the image formed? Image is formed between center of curvature and focus. When the object is kept beyond center of curvature, image is formed between the center of curvature and the focus. What type of image it is? See, this was a straight object like this. This is inverted. And it's a real image. Real image means this is actual image which is formed on the mirror. When the image will be formed behind the mirror, that is known as virtual image. Because virtual image means you cannot see image behind the mirror. That is not a real object, a real image. Here it is formed in front of the mirror. So a real image has been formed. That's not virtually something. So this is the case when the object is kept beyond C. Anywhere you do this, it's just the size of the image will change. You keep it at infinity, size will be point size. You bring it near the center of curvature, the size of the image will be increasing, but everywhere this rule will be valid. You take the object beyond C, this will occur. Now what we do, let us shift the object a little here. Exactly at the center of curvature, let's see if we keep the image object exactly at the center of curvature. This is the center of curvature. So if we keep this is the most difficult one to draw, most difficult one. So when you people are also drawing, be careful, because in the notebook also after drawing this becomes difficult because this is very precise. This is a B. The object, rays are going. Now see, rays are passing through the focus. I'll redraw it somewhere if it is needed, but you people, when you will draw it precise, you will get it in the notebooks. This occurs according to the first law, right? Secondly, the rays of light, because the curvature rule will not occur because the image is exactly, the object is exactly at the center of curvature. So the rays of the second ray will have to pass through the focus. If the rays are passing through the focus, then see, what is the rule we had seen? If the rays of light are passing through the focus, then the images become parallel and move. So images are the ray of light becomes parallel and back to infinity. See these are the two rules we are seeing. In the first one, light rays parallel to the principal axis and passing through the focus. Second one, passing through the focus, becoming parallel to principal axis. This is the case. Clear? Now, why am I saying you have to be very specific and there's the most precise one? Because see, here you are getting the image also at the center of curvature. You should get the image at the center of curvature. This is not very clean and neat and very equal from everywhere. Please draw it properly. It's like at the center of curvature, object is kept AB at the center of curvature, A dash, B dash, that is the image is made. Object and image. So where is the image formed? Image is formed at the center of curvature itself. What about the size? See, here the size was smaller. Here the size is, when I say now diminished means size is small. You take the object back to infinity and as far as you can, this will keep on reducing. It will become point size, so diminished. You bring it closer to the center of curvature, this size will increase. And exactly at the center of curvature, when you keep the object will become of same size. So in the previous case, it was diminished. Here it is of same size. Then this is formed in front of the mirror. This is a proper real image that is formed. And see, this is the object that is kept. This is the inverted image. This is how the inverted image has been made. So why am I saying? Because class, when you have to show ray diagrams to your teachers in the examination, so your ray diagrams have to be precise. This should match. This height should match. So why am I saying be careful with this? Because in the other cases, you get the image. But exactly getting of the same size here becomes difficult, and that too at the center of curvature. When it was between, so you can draw between anywhere, but exactly at the center of curvature, this needs precision. Now class, reverse is going to occur. It means now I'm keeping the object at between the center of curvature and focus. This is the object that is kept. Now coming to the rules. Ray of light passes parallelly, so it will bounce back and pass through the focus. Fine. What about second ray of light? Second ray of light has a tendency to pass through the center of curvature. It will retrace its path. Now see. Not here. This has occurred here, the intersection. This is A dash, B dash, which is the image. Now look at the properties of this image that has been formed. Where is the image formed? Beyond C. Can you see this is reverse? When the object was kept beyond C, the image was formed between center of curvature and focus. When the object is kept between C and F, the image is formed beyond C. So this is how you can remember. So image is formed beyond center of curvature. Secondly, what about the size? That time the size was decreasing. Then it became equal at center of curvature. Now the size is so enlarged as compared to the object size. So this is enlarged. It's a real image. Properly it has been formed in front of the mirror, and this is inverted. Fine. Last case. See, now we are keeping till here we have reached. Fine. So whenever we are keeping it between the focus and the pole, suppose here between the focus and the pole, you have kept the which diagram? Chavez, mention it. No, we are fourth one. We are at the fourth one. Third one, just wait. See, object is there actually. Wait. Object is there. Rays are passing, going parallel. The way we perform the drawing, the ray diagrams drawing, the ray is parallel to the principal axis. So it passes through the focus. The ray of light has passed. Second ray of light passes through the center of curvature. I told you, remember, center of curvature, whenever rays of light will pass through the center of curvature, it will retrace its path. So see, this is retracing its path like this. But in between the process, an intersection has occurred over here. See here. So at this point, when both of these rays are coinciding, you are getting an image. This is the image that is formed, inverted real enlarged beyond the center of curvature. Is this clear now, Shaved? Any doubts you want me to repeat? Something you have not understood? Yes, Shaved, have you understood or not? Understood, no? If any other student also has any doubt, please let me know. Though I know you people have done these in your 9th standard and I think 10th standard only you had optics, but still so many rules were not included in the lower classes. So this is the object AB. So according to this, light ray will be parallel. This will pass through the focus. Fine, please draw it properly. Here there is some lagging because of the graphics of this. So this is coming, this is passing through the focus. Second, according to the second one, second ray of light passes through the center of curvature. Now see, it will be retraced. See, can you see intersection anywhere? There is no intersection.
No, ma'am.
No, see, this is one ray of light which passes through the focus. See, this is parallel to the principal axis passing through the focus. Second ray of light, this is not coinciding. So we cannot conclude that there is no image formed between this. When you extend it, when you extend this, there is an image formed behind the mirror. That is not real image because this is formed somewhere behind the mirror. This is a virtual image. So what are all the characteristics? When you keep the object between the focus and pole, you obtain the image behind the mirror. The image is obtained behind the mirror. What are the characteristics? It's enlarged. This is also enlarged. This is not inverted. This is erect. This is erect, straight. Till now, we didn't obtain this case. Also, this is not a proper real image that is formed. This is virtual. So virtual and erect image in this case. These are the 4 cases. Write down wherever you people are having doubts. Let me know the point. Just mention the number A, B, C, D, which one? 1, 2, 3, 4. I'll discuss it. Yes, real images are formed in front of the mirror, whether it's formed above the principal axis or below the principal axis. That time also you consider it real. Virtual images means the image is actually not formed. See, in the last case, did you notice that we extended the rays and then an image was obtained? Actual intersection of light rays do not occur. So that when the actual intersection of light rays do not occur, that is known as virtual image. Real images means that rays are actually intersecting. So that occurs usually in front of the mirror.
Yes, ma'am.
Ma'am,
Yes, Priya, what's your doubt?
actually, I got the image, ma'am, but it is not exactly in the middle of C and F. It is towards F. It's no problem.
It should be between them.
Like it should be middle.
It's not necessary that it has to be in the middle. I told you it's
Okay,
between C and F.
okay, ma'am.
in the formation of image by convex mirror. See, this part, the inner part is silvered. Look here, when we were discussing the convex mirror, concave mirror, the outer bulge part which was present, this was silvered. Now in the convex mirror, the outer part which is available for reflection, this is present. Inner part is silver. So in this convex one, you keep the image anywhere because all the center of curvature, focus and everything, this is present inside. So outside you keep the object anywhere. That's why you do not have all the cases. Like see, if the object, we cannot keep the object behind the mirror, no, where the silvering is occurred. That's why the object is kept in front of the mirror. So anywhere you choose, you will get the same case. So for convex mirror, you just have to remember 1 or 2 points. Concave mirror, we change the object's image, object's position. So see, first ray of light. So again, the rules will be same. It's just that for the formation of images at the focus and center of curvature, we'll be drawing the virtual images. Like see, if this ray of light is passing through the, this is parallel to the principal axis. This is the object AB. This is parallel. So what happens? The images, the rays of light, they pass through the focus. This is the rule. But see here, the rays cannot go behind the mirror. The rays cannot go behind the mirror. So see, instead of passing it directly through the focus, we have to take the virtual image. See, this is how the ray of light has passed through the focus. Second image, you will take it from the center of curvature. This is the center of curvature. So again, we will not take the ray exactly there. So if the ray of light is going through the center of curvature, this will retrace its path. So here the image is formed. So this also has no location. You keep on changing its position, you will get this formation of image anywhere. So if you keep the object in front of the mirror, see, object here is in front of the mirror. So image is formed behind the mirror. So depending the size and everything, this depends how you have kept the object. If you have kept it very near, if you've kept it very far away. So in convex, you do not have the cases. That's why, because one only object position is there, that is in front of the mirror. So one image formation will also be there. And see, these are dotted lines. These were the lines which I was mentioning to you earlier. These are proper concrete lines because these are actual rays of light which are present. These are just virtual. These we have extended. So the image that is formed is also virtual. Size, you can see the size has decreased. So this is diminished. And this is not inverted, this is erect. So erect, virtual and erect image we'll obtain. Write it down. All those people who have completed, you can leave. Tomorrow we'll continue because the next topic is lengthy. Rest of the students, your class is after half an hour.